Hi, and welcome to the next video in our series. And what we're going to do is talk about scripting, right? So normally a system, right, has a large number of text files, right? So searching for a particular text file can be a tedious task, right? So we can actually use text files, search text files based on criteria specific using regular expressions, right? So we're going to do a little bit of that in using the find command with Linux, right? That so we can uh, demonstrate, demonstrate how to locating and manipulating multiple files supporting common values for criteria like name, type, size, timestamp, and we use the find command to be locating files based on those pretty much that criteria, right? So let's make sure I'm connected to the right machine. Yep. All right. And let's see, command terminal. And then I'm going to find files starting with no, right, for a username root, right? And to find these files, I'm going to type in this command here. So let's see, user root name. I think it's this. Oh, okay, now it works properly. Okay, perfect. So now it says you're in the password. Of course, the password is not going to show. Perfect. So usually when you're entering commands with sudo, right, usually you're prompted to provide the password, but not necessarily if it'll appear in the same places, right? So now we see a series of files back to what we're doing here. A series of files with GNOME and their names are listed now. So I'm just going to clear these out. All right. And then I'm going to, let's see, define F. Actually, you know what? I'm just going to do it the lazy way. There we go. Okay. Perfect. That's a lot of files, right? Okay. Just going to clear that out again. I just wanted to just show. So now all the files for the username root was listed as far as the output of that command, right? So now I'm just going to find files that were modified several days ago. So I'm going to type in, let's see, um, perfect. So we can see daily, monthly, weekly, temporary. So the output of this particular list is files that were modified more than 60 days back, right? So let's see, let's clear this out. Right, so now I'm going to find files that were modified in the last hour, right? And then let's get a detailed listing. So let's go back here and then enter in this command. That's it. Yeah, it's good. There it is. Perfect. Let's see all of these great files here. All right, perfect. And let's clear it out again. All right, so now I'm going to take a look at all files that have more than 1 MB. It should be quite interesting. So let's see. List. Of course, right? Wow. Yeah, it's pretty much going to be pretty much every file, right? So let me clear that out. Just wanted to to see that. Now I'm just going to look for a specific type of files for a particular user. So I'm going to find the text files for the root user. So I'm going to do, let's see, mix this out. And there it is. That was pretty quick. All right, so now we got the text files that belong to the root user, right? So let's clear this out. And now we're just going to find empty subdirectories in a specific directory. So I'm going to use, let's see, tmp. There it is. All right. Perfect. So now we have a list of empty subdirectories here under the tmp directory specifically, right? So now I'm just going to find executable files. So let's see. Equals X. All right. So now the list of executable files are shown. And just one last time, just going to clear it out. Now we can take a look at finding files and commands on the Linux system, right? So usually a small Linux distribution can contain thousands of files. So for example, the USR directory of distribution, it can contain over 50,000 files, right? So the complete installation may contain over 200,000 files. So locating a file can be difficult with such a large number, right? Such a great volume. So similarly, we can search for a specific command to find out which command will be executed when we enter a specific command. So we're just going to locate files now and commands in various directories. So let's see which one. Let's see. Take a look at that one. So to give us the user, the bin, and then it'll, excuse me, it'll show yum. So now we can see that the first occurrence where this command appears is displayed. And now we can find out all the locations where a specific command occurs. So we can do, let's see, there it is. So it looks like it's just that was, so there's only one instance of that particular command. So just going to clear this out. Now the where is command allows us to locate more information, just the location of the command, right? So to find more details of a command like yum that I've just typed, we can do where is yum, and it'll tell us exactly right here, right? So the output displays the location, the name of the configuration file, the location on the man pages for the command as well. Let's clear this out. So there's also going to be instances where you need to find files on your Linux system using their names or path, right? So to find these, we can do sudo find, then name. You could do yum, right? And we can do that here. Perfect. And then we see the output, which displays the names of the files and the locations, right? So we saw that. We can clear that out. So using a find command, I mean, you can also find all the directories, right? So to find the directories, you can just type in, let's see, type D for directories. And then now, there we go. So the D parameter just signifies, as I've mentioned, directories. It's an argument for the type parameter. Therefore, the type parameter allows us to specify that we're searching for the type directories, right? So now we see displayed all of the directories that we wanted to have appear before us. So now that we can clear that out, now also using the find command, you can also find files by user and groups. For example, to find all the files by the user root, we can use the command, let's see, tc user root. And so that was pretty quick, but it was a lot, but quick. So as you can see, back /etc is the name of the directory where we'll search for the files. So the user parameter specifies the name of the user, which is the root in this case, of course. And there are a lot more combinations that we can actually use to find files. We're just going through these examples, just a few of them we want to just gloss through. Now, when you use the find command, it's searching for the files and directories based on a given condition, right, of the file system. So we can actually speed up the search using the locate command. We're searching for the location of the files from a specific database. So for example, to find all the files in the etc directory, we can type in, let's see, there we go. So, so since the etc is the name of the directory that we want to search for the files, that was the last thing we placed there. And sometimes you may receive an error. If you do, you can enter in yeah, but that's what you normally would. But since I did get an error, then I'll just repopulate it for me to enter in command. So what we did notice that all the files in the etc directory were listed. And you can also find the database that the locate command uses to find files and directories. To find the location of the database, we can actually place this here. Actually, that's wrong. Perfect. All right, so we see how many directories, how many files, the bytes and the file names and the bytes used to store the database. And the databases may differ in different Linux distributions. So for example, in some of the Linux distributions, you may find the database name to be slocate or mlocate. But what we're going to do now is search for specific text in the file. So to search for specific text in the file, we're going to create regular, simple expressions containing several notational elements. So we're going to determine the parameters related to a particular text in the yum type of file. So let's clear this out first before we get started. Then we're going to do one of these here. Then we do TC and all right. So various parameters can be used with the grep command, and here this particular parameter displays the line number of the line that contains the search text. And we'll notice here at the number 7 at the beginning of the display, this is the line number of the line that contains the specified text. So instead of displaying the line with the search text, we can actually simply count the number of lines really in which the search text appears. So we can count the number of lines using the -C switch. So for instance, we do one of these here, and then we pretty much just do exactly what we did before following that. Perfect. So you see one, right? So you see just one line where it has that, and then but we can actually try the number of words that start with the P, the letter P in the file as well. So we can actually do, let's see, then P. I think that's, yeah. So it's 7, right? So it shows us the count of words starting with the letter P. And then let's clear this out so we can go to the next. So we can also list all the blank lines with their line numbers with, let's see, let's do And then we'll put something else in the parentheses here, not parentheses, the quotes. Let's see, where do we find the, gosh darn it. All right, perfect. So we have the arrow, we have this here, right? Then everything else is about the same. Let's see, is that correct? Yeah, that looks about right. Yeah, that looks about right. So it doesn't return an output. That means there's no blank lines in the file. But we can also simply list the lines that contain a specific word. So we can do, let's see, I'll just, perfect. All right, so now we see in the command, the word proxy is being searched without quotes, right? So the line containing the word proxy is now shown at the output of the command. And as we can see, proxy for the hypertext transfer protocol and the port for the proxy as well. So now what we're going to do is search for specific criteria through a file content or a file system. So in the previous, the task I just completed, I used grep, right? And this task I will use egrep. So there's a distinct difference between the two. When we use grep, special characters like a question mark, a plus, they lose their meaning, right? To use special characters as meta characters, we need to use backslash, question mark, backslash, the plus sign. With egrep, we don't have to use these, right? These special characters. So to search for specific criteria through a file content or file systems, we can do a few things. We can do, and I'll have future videos on these as well, dive a little bit deeper into these. Okay. Perfect. So it gives us the same as far as the last command that I used. In this command, we use the pipe, which acts as an OR command. And this means that the egrep will simply search a specific file. So in this case, this file here, yeah, there it is. This file here and list the occurrences that have a proxy in the name as well. So now I'm going to attempt the same command just to give you an idea with using just grep, but I want to change a few things. Let's see. I'll do that here. So as we can see that there's no result because it can't interpret the pipe, which is what we have here. Can't interpret that. So it's not going to return to us anything. It's going to be like, well, I don't, it's like I'm speaking Spanish or speaking English, and we've never divulged ourselves into the other language, by vice versa. So we don't know what we're saying. So there's going to be no real communication, right? So we're going to move forward with counting the number of lines in the file we've been taking a look at so far through the last few steps that either start with a 1 or end in 01. And so we're going to type this command to do so. Let's see, this one, I believe, and then pipe, then again. Zero. So that's the number of lines that either start with 1 or end with 01. Now, we also want to note too here, something I didn't mention. The use of single inverted commas in the command as compared to the use of double inverted commas in the earlier commands. Just want to notate that because it's again something I'm going to do and going to comb through in a later video. But we noticed that to get back to this exercise, the output returns 0, which means that the specified criteria, of course, were not met. So what we're going to do now is just try to find 2 words that are simultaneously in a file. We can do it with, let's see, proxy. Let's see. Perfect. So we see the limit of 3. So the number of occurrences for both words were found, right? And now I want to also note that the egrep or the egrep and the fgrep now. So we have the regular grep, then we have egrep, and now we have fgrep. They're equivalent to minus e or minus f, which you'll see in a second. So the fgrep command is similar to the GRE, to the first one, right, to the original grep, but it does not process any regular expression like meta characters as being special characters, right? So to grep, I'll give an example. So if we do this here, you see 1 here, all right? So now with the 1, it's just the output of the fgrep with the minus C command. And to show the total number of lines where the proxy word is displayed, right? So now to find 2 words with fgrep, we're going to do, let's see, we're going to use a pipe. Then I think that's it. So 0, right? So now we see that this command is, while it's trying to find both words, the proxy as well as the install only, and our file, it cannot determine 2 words and therefore return 0 as the search result, right? So that's grep. Those are the greps, at least the ones that we've crossed over or went over so far. So regular grep, egrep, and fgrep. So now we can move on to scripting. I was going to say shifting. Scripting. So bash is a shell, right, which acts as a command language interpreter. So when a user executes a command, the output is generated as the output of the command. The bash can execute individual commands as well as commands from a file, which is known as a script, right? So I'm going to write a simple bash script, right? So let me clear this out. All right, perfect. So I'm going to do something like this. Perfect. So now we see, actually, let's see. Okay, perfect. So we created a new script using what's called the VI editor, right? And I pressed I, and which changed it, we saw at the bottom here, to insert mode. So now it's going to always be, was going to be hashtag exclamation point /bin/sh will always be the first line that tells the OS that the script needs to be executed by the Bourne shell. And in this case, as it's mentioned, which is the default location of the Bourne shell, the characters I just mentioned in a second. So I'm going to type, actually, see here. There it is. Okay. /. Okay. All right, perfect. So now I'm going to type echo. Okay. Actually, let me try again. Okay. All right, so now to save the file, I'll need to exit the insert mode, and I'll be typing this here. Let's see, should give me, there it is. All right, perfect. So now that we're out of that, we're back in terminal mode. Actually, let me do it again. Perfect, there we go. Now we're back in terminal mode. So next we need to change the permissions on this particular shell script. Before a shell script can be executed, the user must make the script executable. So to do this, we're going to change modifications, 755 script, H. All right, so now the script is made executable, but it can be, not but however, it can be executed in two ways. So the first method is to use the bash command. And to execute the script, we can do this here. Perfect. Good morning. There we go. And it says that about line 4 because I had made, I believe I pressed enter to kind of space out the lines, but I placed nothing there, so it's going to show line 4. It's not found. But nonetheless, the script ran and printed the output on the console. So with the use of the echo command, you usually need to put the string of characters in the quote, so it could be printed in the verbatim manner that we entered. So I didn't mention this, I believe, but I wrote it normal way when I pressed the space, but on this line, I used tab instead of the space bar after the word good. So let's close this out. And then I'm just going to do this command here. H, there we go. Now notice that the method is the same and I get the same output, right? For that one. We can also use a third method that's used by various Linux flavors. We can also create a subdirectory named bin in our home directory. Then we can move the script to the subdirectory. So actually to create one, let's see. So now we have the mkdir bin, and then we're going to clear this out, and then we can do list. And then that'll list the files in a home directory, right? So the output is, when I place in command, is here. Now I'm going to move the file to the bin directory with move command script bin here. Perfect. All right, so now the mv command does not provide any output, but we're going to verify that the file has moved to the bin directory to list the files in the home directory. So it's going to take a look there. And as you can see, it has a bit changed up here. So that means that the script.sh file does not exist in the root directory anymore. But with the use of the mv command, it has been moved to the bin directory, right? So now that we see that, let's clear this out. Then we're going to do that to the bin, to navigate to the bin directory. All right. So to execute the script now, just let's see, I gotta spell it right first. There we go. All right, now we see the good morning again. All right, perfect. So now we notice that the script ran without the bash command or which is the // So in the bin directory, the script can run on its own by simply executing it, right? So, all right, perfect. So we're just gonna, I should have added comments to it because scripts can have comments, which are statements that don't get executed. So just in case, let's say you wanted to leave something for the next person that's going to take a look at the files, right? And you can leave little notes for that person that's going to be there, right? So so now we're just going to open the script sh file again. So we're going to take a look at it, and pretty much what I started off with, typing the echo good morning, then the WQ, and then I'll get back into insert mode. Perfect. So then I'll type, let's see, do it here. This just test script. All right. So this and this here, when I started off with the hashtag, that's how it'll be commanded to know this is just a note or a comment rather, versus a command, right? So you'll see when I take a look at the file, it'll only show the good morning or the WQ, but it won't show this is just a test script. Well, it may show it, but it won't show it as a command, rather, as far as how it shows up in echo with anything that's between the quotes. So let's do perfect. All right. So now let's go back to the terminal window, actually. There it is. And there we go. All right, perfect. I always forget that extra step. So now I'm just going to execute the script. Perfect. So there we go. And we'll notice that the output doesn't show any comment, right? So let's use the parameters. So shell scripts, as I mentioned earlier, can be written once and then reused as many times as possible. The advantage of a shell script is also that you could pass different parameters to get different results. So let's put this here. Right, there we go. Let's clear this out. Perfect. So we have a new file for parameters. So we're going to go into insert mode. Then we're going to do this here. Then dash echo. Then we're going to put some things in parentheses here. There we go. I think that's it. No. Okay, perfect. So, let me actually make sure I hit this. Always forget that step. Okay. Okay, I'm not sure. Supposed to exit. All right, perfect. So now we're back on the command prompt, right? So next we need to change the permissions on this shell script, right? So before a shell script can be executed, the user must make the shell script executable. So I'm going to actually start typing. Let's see, so 755 program. All right, perfect. So well, now we see that the script provides different results when the parameters are passed on. So let's do, actually, that's not what I wanted. Okay, yeah. Okay, it gave me the same. All right, so we take a look at the output that's displayed. The output counts the number of parameters and then displays them. So now I'm just going to use quotes. All right. And now we notice that the output counts the parameters in a quote as one parameter. So it also out, it also displays the parameters within the quote. So now I'm just going to type this here. Let's see. So now it just counts, as it shows two parameters, right? Counts two different numbers. Well, this is on its own, and then these counts as one. So that's why it brings up two parameters here. So in all three cases, the output was different. And in this case, there are two parameters and then the value of the parameters, right? So now we're going to capture user inputs in scripts. So you can also capture user inputs. For example, prompting a user to enter the name and then displaying the name. And now I'm just going to capture user inputs in the script, as I mentioned. So let's clear this out, and then let's see. Let's do this one. I'll never get used to that. And then all right. So now, actually, you know what? I just noticed I should have entered that using the script. So I'm going to create another script actually for just a moment. All right, perfect. So let's create the script here. All right, perfect. So I'm going to change all of this for us to do. We want, actually, let me go back here to insert. So let's do, should have named it bash, but it's fine. I'll do it here. All right, perfect. All right, so now that we have those there, let me that there. Perfect. So now we're back at the command. So just going to do this one again to test it out. Actually, makes sense. Let's see. Yeah, it should. All right, let's see how we can fix this. All right, perfect. So I rectified exactly what happened. Created the wrong script, and I went back and rectified that. So I entered in the command from before, and it brought me back pretty much nothing. So I'm just going to run this command now here, and there it is. Hello, please enter your name, which is exactly what I've commanded in the script that I created for the test, right? And naturally, I'm prompting to enter my name. So I'm going to type in my name, right? Press enter, then it says hello. So it gives me a welcome message. So I'll clear this out now that we verified that. So I'm going to create another script named fruits. Let's see. It lets me. All right. Okay. There we go. All right. So we're going to do a few things here. Let's start up there. There we go. Forgot to do that. So we can do this properly. Echo name 3 fruits that you love to eat. Three. First fruit you like is fruit 1. Then echo second. I cannot type today. All right, perfect. So just going to save the file. Let's see here, there, and then we're back. All right, so in this script, I'm accepting multiple values using the read command, and the read is going to split the values on the white space. So now that I've created the file, assigning the execute permissions using the command, I'm going to actually do this here. Then I'm going to execute it, of course, because why else? Name 3 fruits you love to eat. I love apples, good for fiber. I love, okay, first fruit you like to eat. Let's see, I should have named 3. All right, let's try, let's actually clear it out. Clear. Let's step up. All right, so apples, love pineapple. And oranges, let's say. All right, and let's see, perfect. So it gave me, I thought it was going to ask me something else as far as the secondary question, but that's fine. So it gave me the response when I told it what 3 fruits that I like, and it gave me the first, second, third. I could have put watermelon. Watermelon is a great one. Very, very, very good nutrients to watermelon. I highly recommend it. All right, so we noted that the enter values that I place as far as the fruits, they're assigned to their appropriate variables, right? As far as the first fruit, second fruit, and a third fruit, which is good, right? Everything is working properly. So this allows us to move on to our last exercise, which is going to be piping, right? And in the advent of piping, so Linux shells that use pipe as an operator between two commands, right? So where the output of one command is the input of the second. So redirects are meant to direct the output to a specific file or take the input from a specific file. So we're going to do a bit of that with piping the output of one command to the input of another as far as this particular exercise. So let's get started with clearing this out here. And we're going to redirect the standard output of the first command to the standard input of the second command with this particular command here. Pipe. There we go. Actually, let's see. There we go. All right, so now the more parameters used for pagination, right? So I'll need to actually press enter to continue reading. So it's pretty much just gonna keep waiting until I press enter to give me more, right? So I can usually press enter to complete, right, the output, or terminate with Control C to terminate the output, and then I'll be back at the command. Let's see. Could have given me that option here. I don't think so. Actually, let me try on my keyboard. I'm on a Mac computer, so not sure if it'll work. Okay. Just trying to click on anything so the menu could go away. There it is. Let's see. All right, so this works. There it is. We're back. So let's close this out before it gives me a headache. So now I'm going to use the output of one command as argument to another command. So we can do this. We're going to use the output to argue another. So after clearing that out, we're just going to do this here. And grep. Grep is back again. All right, perfect. July 23rd, 2015. All right, that was quite a while ago. So this command uses piping with the grep command. It'll find any file that the word user has in the name. So now we're going to use the xargs command, which you'll see here in a second. So it actually generates an argument, right? Using the standard output for a command. It's typically used with the pipe operator. So pipe, xargs, and cat, and then it'll bring back up everything that I've done prior as far as the name and the fruits. For the cat parameter, it reads the contents of the file displayed in the list parameter. And now we're going to send the output to both the stdout and the file. So let's start with clearing this out. And now we're going to redirect the standard output to a file on the screen at the same time. We're going to use the T command in this particular output, or input rather. You'll see here in a second. Then we'll use the pipe, output, text file. All right, so the T command, it reads the input and then writes the standard output also to the file that's specified, right? So as we can see here, the standard output is generated along with this file named output is also generated as well. I could try to find a needle in the haystack to find it, but it's somewhere in there, right? So I'm just going to clear this out now that I've demonstrated that. So let's see. Oh, there it is. Okay. So it shows the output text and then also the scripts that I created with the fruits, the parameters, the script, the test, and all of that jazz. So now and we also see the output text file that's now created with the input from the T command that I just put. So now we're going to view the contents of that text file, right? So we're going to do that with this. Then we're going to take a look and see what's in there. All of these guys are in the output text file. So it contains the same output that was displayed before. So now we've reached the end of this particular video for scripting. Thank you so much if you're still here. We've done a few things. I'm just going to go over a brief recap of what we have done. We've performed a search, multiple searches to Linux, right? We've performed scripting, and we've also done some piping. So now we've found out different ways, various ways of using the find command, finding files or commands on the Linux system, writing simple bash script, capture user inputs and scripts, as well as a few other things as far as with the piping and the scripting as well. So thank you so much again for watching this video as part of this particular series, and I'll see you on the next one.